Good morning. So we're here to talk about prime numbers, composite numbers, and a prime factor tree, which we'll come to in a minute. First of all, we need to know the difference between a prime number and a composite number. The main thing is the prime number has got two factors, itself and 1. So two numbers that multiply to give it. So for instance, is 10 a prime number? No, because it has 4 factors. 1 times 10 and 2 times 5. All those are factors of 10. So 10 would be a composite number. So because it's got more than 2 factors. Okay, so examples, prime numbers, for example, 3, 5, 7, 11, 13, 9 would not be a prime number because remember 3 times 3 is 9 as well as 1 times 9. So it's all about counting those factors. If we're just stuck with 2, that's a prime. Is 1 a prime then? Well, actually no, because 1 only has 1 factor. So technically it's not. 1 times 1, the only factor there is 1, therefore it's not. So the first prime number is 2. 2, 3, 5, 7, etc. Composite numbers was possibly more composite number than prime numbers, that's debatable, but composite numbers 10, 15, 12, anything divisible by 2 except for 2 is a composite number if you think about that. So for instance 4, 8, 6, 10, all the even numbers after 2, they'll be composite numbers. Interesting fact, any number in the world can be got, whole number can be got by multiplying prime numbers together. So think about that, any number. So 20, for instance, can be got by multiplying just prime numbers. 200, a million, they can all be got by multiplying just prime numbers together. So let's look at that. And to get that, we use a prime factor tree. So for instance, 10 can be got by multiplying 2 prime numbers, 2 times 5. Okay, that's easy. So that's prime, it works for that one, but that's too simple. Let's try something more difficult. 48. Now I'm not sure, but I know my times tables. I know that 12 times 4. But of course, 12 times 4 is not, neither of those are prime numbers, they're both composite. We've just learned they're composite because they have more than 2 factors. But if they have more than 2 factors, we can break them down. So 12 is actually 6 times 2, and 4 is 2 times 2. And 6 is actually 3 times 2. So if I've written that out, that 12 became 6 times 2, that 4 became 2 times 2, this 6 becomes 3 times 2, and then does this multiply out to give 48? 3 times 2 is 6, that answer times 2 is 12, that answer times 2 is 24, that answer times 2 is 48. So yeah, it does. But this is a bit awkward looking, and that's why we use something called a prime factor tree, which removes all this multiplication signs and makes it flow a little bit better. So let's look at prime factor 3 for 200. So we put the number at the top of the tree. Now I think of 2 numbers that multiply by to give 200, and I separate them into 2 factors here. So I think, 20 times 10. Now I don't write the multiplication side, but I know that these 2 multiply to give 200. And then I look at 20, and I think of 2 numbers that multiply to give 20. So you see the way the tree is growing some roots. 4 times 5, and I write them like that. 10, I switch to it, and I get 2 times 5. So that's split up. Alright, 4. Well, that can be split up again. 2 times 2. So remember, these 2 numbers multiply to give the number above it. 4 times 5 is 20. 20 times 10 gives 200. Alright, now I've stopped here. Why have I stopped? Because I have reached prime numbers at the end of all my branches or roots. That's a prime number. That's prime, 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 prime. Each of these only has two factors, one and itself. Now I could keep going, but it's pointless, because watch. Two numbers multiplied to give 2 are 2 and 1. Oh, I still have 2. Two numbers multiplied to give 2 are 2 and 1. Two numbers multiplied to give 2 are 2 and 1. Two numbers multiplied to give this 2, 2 and oh, this is going to go on forever. So that's why I stop with the prime numbers. I don't need all this. When I get a prime number, I stop. I should never have the number 1 in a prime factor tree. Now what I need to do is finish off like I've written here. 200 can be obtained by multiplying prime numbers. 2 times 2 times 5 times 2 times 5. So let's test it. 2 times 2 times, well, I'm going to put the 2's in order, and then I'm going to multiply by 5's afterwards. Just neater. 2 times 2 times 2. 2 times 2 times 2. Okay, I got it right. 2 times 2 is 4. 4 times 2 is 8. 8 times this 5 is 40. And 40 times 5 is 200. Boom, I'm correct. Now those of us who like to challenge ourselves and write things properly in maths would notice that I can use index notation to write this. That's 2 by itself 3 times, so 2 to the power of 3, or index 3. And that is multiplied by 5 by itself twice. Either of these forms of answer is correct. I prefer this one, but either of them are correct. So that is a prime factor tree, the difference between prime and composite.